This is question 1 of the June 2015 Unit 2 Physics paper. On screen now is a mark scheme for the question, so please mark your work. If you got the question correct, I suggest you move on. If you got parts of the question incorrect, please listen to the rest of the recording to find out how to get the question correct in the future. In the first part of the question, you're given a figure 1, and it says shows the current potential difference graph of the three wires A, B and C. Using figure 1, how can you tell the temperature if each wire is constant? So what do you notice about the three lines? Well, they're all directly proportional, they're all straight lines, and either one of those things will get you the mark. But the fact that they're straight lines means that you've got constant resistance. And to have constant resistance, you must have constant temperature. Because you know if the temperature increases or decreases, then the resistance will change. So how do we know that they've got constant temperature? It's because they have constant resistance. So let's just write something down that we get as the mark then. So we can say that the constant gradient means constant resistance. I'm just going to put R because you know what that means, constant resistance. And constant resistance essentially means that the temperature of the wires is not changing. And that will get you 1 mark. You could get a mark for constant gradient or constant resistance. So the next part of the question says which one of the wires A, B or C has the greatest resistance. I want you to write down the correct answer in the box and then give a reason for your answer. So we need the equation that links current, potential difference, and resistance. That equation is V equals I times R, where V is potential difference, I is your current, and R is your resistance. Quickly rearranging that, we get R equals V over I. Okay, and so therefore we can work out which one of these will have the greatest resistance. So what we're looking for to make a great one is a relatively high V and a low I. But if we track along here, you can see at that point there, all potential differences are the same, and C has the lowest current, the smallest current, and A has the highest. So if this is a large number, if your I is a larger number, like in A's case, then the resistance is going to be smaller, whereas if it's a smaller number, like in C's case, then the resistance is going to be greater. So the answer, the correct one is C. That will get you 1 mark. And then to explain why, and the idea there is for the same PD, or voltage if you want to write down V, that's potential difference. For the same potential difference, C has a lower current, and that will get you the 2nd mark. That brings us to the end of that 2-mark question. Part 1b is a nice easy one. It just asks you what the unit of resistance is. You should know that the unit of resistance is ohms, you just need to learn that, or you could use a symbol omega. Either one of those gets you that mark. That should be a nice straightforward question, please just learn that. For question 1b, it says the resistance of a wire depends on many factors. Look at table 1, which I've included at the top there. Which two wires from J, K, L and M show the resistance of a wire depends on the length of the wire? Okay, so what we want to do here is we want to look at some that have got a difference in length but have got the other factors that are the same. So you can see here, if we look through them, we can't compare these two because they've got different diameters, whereas these two here have the same diameter. This one we can't use because it has a different material, and say we can't use that one because it has a different diameter. And if you look at K and L, does their length change? Well, yes it does. Does their resistance change? Yes it does. So the ones that we can use are K and L. That will get you 1 mark there. Why have we chosen K and L? I'm just going to switch to blue. The reason we've chosen K and L is because they have the same diameter, the same type of metal, and only length changes. So only length changes is what the mark scheme is actually looking for, but I personally think that the logic that you use to get there is that they have the same diameter, which I could put DIA, do you know that means diameter, and they're also the same metal. That's how we knew which ones to choose. The next question has a student looking at the data in table 1 and they wrote a conclusion, which I'm just going to highlight here. So the resistance of a wire depends on the type of metal from which the wire is made. The student could not be certain that her conclusion is true for all types of metal. So yes, what extra data is needed for the student to be more certain that the conclusion is correct? So looking at the table, we can see that we've got two types of wire. We have copper and we also have constant tan. And we can see that the resistance does vary for those two types of wire. But we've only tested two different types of metal. So it's in order for us to be certain that our conclusion is correct for all types of metal, we would need to test more types of metal. So we need to test wires made from different types of metal and more of them. So in order to get the mark, what we're looking for there is we need to measure the resistance, which we can use R for resistance, of more wires made from different metals. Put diff there. I put M for metals, but you know what that means. And that will get you the mark. So the idea is you need to test more wires made from different types of metals. So in one part C, it says the resistance of a wire can be calculated using the readings of an ammeter and a voltmeter. It says complete figure 2 by drawing a voltmeter in the correct position in the circuit. Use the correct circuit symbol for a voltmeter. Okay, so this is just one mark. What we're looking at is we want to work out the resistance of the wire. So the voltmeter needs to be across the wire. Now remember, we always connect voltmeters in parallel. So you just want a circle with a V, because that's the correct symbol for a voltmeter, and we're putting it across there. Now that should touch the point in this bit here, and it should also touch there. Mine's overlapping. It's quite difficult to draw on the iPad, but they should be touching the wires perfectly, and that will get you the mark. Obviously you can have it going down this side here as well, into the right place. Like either one of those will get you the mark. For the last question, it says, in a circuit diagram, a wire can be represented by a symbol for a resistor. In the box below, draw a circuit symbol for a resistor. Now, I'm not going to draw it in the box because it's quite difficult to do that on the iPad, but you can see the resistor is just a rectangular box like so. And remember, those lines should be touching, and that would then therefore get you the mark. It's just a straightforward resistor, which is just a rectangular box, as I've drawn on the screen. That brings you right to the end of question 1, so the recording will finish here.